Welcome to qnawire.
So now we'll work on problem 40 from chapter 20. In this problem, we're given the following half reactions and associated standard reduction potentials. And we're given three half reactions. And we're asked to write the equation for the combination of these half cell reactions that leads to the largest positive EMF and calculate the value. So what we want to do here is go ahead and combine the 0.49 and 0.86 values, the first and the third reaction, because those are the largest absolute values. And when we combine those, we can make sure that we do the subtraction correctly, and we can get the largest possible value. So to combine these in the largest possible way, then the first reaction, the 0.86, since it's negative, it would have to be involved in the oxidation. So we can go ahead and flip it and write it down here. So this is for A. So we have AU plus 4Br minus, producing AuBr4 minus plus 3 electrons. So since we're flipping this reaction, we can go ahead and put the potential of this reaction as the opposite of what we put down, or we can put in parentheses that it's negative 0.86 for the reduction. So the next reaction we can leave as is. We have IO minus plus H2O plus 2 electrons, producing I minus and 2 hydroxide. Now for this reaction here to work, what we need to do is make sure the electrons will cancel. So since we have a 2 and a 3, we can multiply the top by 2 and the bottom by 3. And we simply have to combine our reaction here. So we have 2 gold plus 8 bromide, plus 3 iodate, plus 3 H2O, produces 2 AuBr4 minus, 3 iodide, and 6 hydroxides. So this is the total reaction, and to find the potential of this reaction, we would get, we're not told that it's a cell, so we get 0.49 first, since that's the reduction reaction. And then we can put minus minus, or we could realize that it's this is the reduction value. And we get 1.35 volts as the largest possible value here. So question part B asks us to do the smallest possible value. So we need to combine the second and third reactions, since these two have the smallest absolute value. So we go ahead and write down the oxidation reaction first. We're going to flip it like we did previously. We have europium 2 plus producing europium 3 plus and 1 electron. And the potential for this reaction is equal to, we'll flip it, 0.43, again in parentheses negative 0.43 for the reduction. The other reaction is the same reaction as we did before. We have the iodate plus H2O plus 2 electrons, producing iodide and 2 hydroxide. Again, to make this reaction work, we need to balance the electrons, so we multiply the top one by 2, and we add the potential for this half reaction as being 0.49. So we add these up, and we get europium 2 plus we have 2 europium plus the iodate plus H2O produces iodide plus 2 hydroxides plus 2 europium 3 plus cations. And the potential for this reaction is going to equal 0.49 minus the reduction value for the first reaction, which is negative 0.43. And our value that we get is 0.92